All right, here we go. So here's video number 2 for the volume lesson 10.5. So the question is, what's the volume of the largest possible sphere that will fit inside of a box that is 12 by 12 by 12 centimeters? So here we have a box, 12 by 12 by 12, standard box. And we want to find the sphere that will fit inside of this. Well, to find the sphere that fits inside, it's going to be the sphere that goes from edge to edge. So if all the way across our box is 12 centimeters, from left to right, bottom to top, halfway across would be 6 centimeters. So the radius of the sphere would be 6 centimeters. So what they're asking is, what's the volume of a sphere that has a radius of 6 centimeters? So we simply take our formula, 4/3 pi r cubed, and we replace the r with 6. So there we go. There's the 6 centimeters. So once again, I recommend you type in the 4/3, 4 divided by 3 first. Take that answer, multiply it by pi, and then take 6 to the third power, get that answer of 216, and then multiply those two together. And there we get our volume. So 904.48 centimeters cubed. And that's it. Simply using that formula, you just plug in the r. So maybe we could pause the video right now and the teacher could walk around the room and make sure everybody knows how to type this in. And if we don't know how to type that in, we can ask for help. Next, we want to find the volume of the empty space around the ball. So the empty space is going to be all of this exterior part. So to get that empty space, we're going to take the volume of the box, subtract the volume of the ball, and we're going to get that empty space. And so to find the volume of the box, we think about our earlier section. This is a rectangular prism because we have a square on the bottom and a square on the top. So we take the area of the base multiplied by the height. So 12 by 12 by 12 again. So 12 by 12 by 12, that's the volume of the box, 1728. Then we subtract that sphere, and then we get the empty space, 823.52 centimeters cubed. So there's our second example. We found the volume of the sphere and then volume of the empty space inside of that problem. So go ahead and pause the video here, give everybody a chance to write down those parts. Then we'll look at this last one. So we want to find the volume of this figure. And this is kind of like a pill type of a shape. And so as we look at this, I'm noticing we want to break this up into smaller shapes. And so in the middle, I see a cylinder because we have a circle here and a circle here, and then it has a height in between. And the height in between is 15 centimeters. And then on the left and right side, we have half circles. So these half circles, what we're going to do is put them together to make a full circle. And so those together will make a full sphere. And so we're going to have our same formula for volume of the sphere, 4/3 pi r cubed. And then over here, the volume of the cylinder, we're going to take the area of the base, which is our pi times radius squared, so pi times 8 squared. Then multiply it by the height. The height is the distance between the bases, 15. And so here's the area of the base, here's the height, distance in between, and there's our volume of our cylinder. Then over here, we take the volume of the sphere, 4/3 pi r cubed, where our radius is 8, and we get that volume of the sphere. So we have the cylinder and we have the sphere. What we're going to do is just add those two together. And as we add these two together, we get our full volume, and that gives our volume of our pill-shaped object. So there we go. Now you can try your homework. And pause the video so everybody gets a chance to write that down. Thanks.